We'll start with a simple example, but one we can at least explore based on, well, actually an example taken from Terry Knight from her paper, Computing with Emergence. Well, basically the idea is that there are two rules, and one rule takes a square and basically moves this square diagonally. So this is one way to draw it diagonally. We could of course draw it in any diagonal because it's completely symmetric, but so this could be one rule. And then the other rule basically takes an L shape and translates that L shape diagonally. So let's see. Yeah, maybe like this. And then we move that L shape diagonally. In this case, in the direction of where the L is pointing. So these are the drawings that will provide the two rules. And then we still have to draw the initial shape. For the initial shape, we'll draw two L shapes. Maybe what I can do is have it start here. Oh, sorry, wrong selection. Okay, so let's start over here. So this can be one L shape, and then the other L shape will be like this. Oops, not enough space here. Okay. All right, so that's the initial shape. So this is basically all the graphical geometric information that we need. We have the information for one rule, the information for the other rule, and then the initial shape. So once we have that, we can get started with the grasshopper model. We have here the SGI tab open. The first thing we have to remember is to first place the SGI setup component. This component basically links to the library and makes sure that everything is properly connected. The front end, let's say, to the back end. So success is true. So okay, we're ready to go. So what we need to do now, of course, is to collect this information. For that, we can just use the normal parameters. So we have curves. So for the first rule, we have two curves. We have the left-hand side curve and the right-hand side curve. For the other rule, we'll have the same, of course. And then for the initial shape, we have we just need one parameter. This will be the initial shape. So we can start collecting all the information. So the initial shape is two curves. We can collect them. Okay, that's the initial shape. Then for the first rule, will be the left-hand side. So the left-hand side is the original square. Then the right-hand side is the translated square. Okay, we don't need that. And then the same thing for the second rule. So the left-hand side is the original L shape, and then the right-hand side is the translated L shape. So now we have collected all the information we need into Grasshopper, and now we can start creating the rules basically. So we go back to the SGI tab, and the first thing we have to do is to take these geometries and turn them into shapes. Shape is basically an object that is follows a representation that is understood internally by the Sortal Grammar Interpreter, and this is the SGI Shape component. There are two components, but we'll use the simplest one for now, just the SGI Shape component. So it takes two inputs, a geometry and an optional reference point. Reference point is only important if there is a displacement between the left-hand side and the right-hand side. I mean, if we did not adhere to the proper relationship between left-hand side and right-hand side, in this case, we actually drew them exactly as we want them to be. So this is the left-hand side, and this is the translated right-hand side. So we don't have to deal with reference points. Makes it a lot easier. So all we need to do is take each of these shapes and each of these geometries basically and turn them into a shape. And as you can see, you can check it by clicking on it, and it should have the right one that becomes green. And that's because, so the S output is the actual shape, that's the object. And then, but it also outputs the G. As you can see, although the input is, in this case, 2 polyline curves, the output is 10 line-like curves. It will structure this shape differently in order. It's a canonical representation that is best suited to do to support the matching, the search and replace. Okay, so now we have all the shapes. Now we can create our rules, and this is the SGI rule. Again, there are two rule components. We're just using the SGI rule. This is the simplest one, and it has 4 inputs. We have to give every rule a name. We optionally can also give it a description. Then we have the left-hand side and the right-hand side. So here's our first rule, and the left-hand side is this shape. So we link this to LHS. This is the right-hand side of the same rule. So we'll link that to RHS. We can maybe bring these things a little bit closer together. And then for the name, we will just use a panel. And we can say, well, let's call this the square rule. We can just link this to the name. And then, yes, we have a rule object successfully, let's hope. So this is our first rule. And then we can just do the exact same thing for the second rule. Here too, we will need a name. So let's call this the L-shape rule. And then we take the same rule component and we just link everything. So this is the name. And let's check. Yes, this is the left-hand side. And yes, this is the right-hand side. And we have our 2 rule objects. So now that we have the rules, we can apply the rule. to the initial shape. So we have to look at rule application. So here is SGI apply. That is the simplest one. It just applies a rule to a shape. And as you can see, input is a rule. So, well, these are two L shapes. So if we are going to use a square rule, then of course nothing will apply. So let's use the L shape rule. Then S is the shape. So this is the shape that we wanted to apply. Oh, look at that. There's the result already. Sub S is optional. That's a subshape. That's in case we want to specify which part of this shape we wanted to apply. Alternatively, we can also provide an index number for rule application. At this moment, it is -1, so it randomly picks one of the possible matches. Obviously, given that there were two L shapes in our initial shape, there are two potential rule applications. That's easy to figure out. And it's kind of a little bit annoying, of course, that it draws things on top of one another. Not a big problem. Output is, so this is the resulting shape. This is the resulting geometry. This is what you can see here. Then it has shape descriptions. So this is something we're not dealing with yet. Then we have a translation vector. That is the translation vector we can use so that we don't get to see the things on top of one another. For that, we can go under shape, and here are there's an SGI move shape. We can of course also move the geometry using the normal grasshopper components, but since we will, if we want to apply another rule, then obviously we want to be working with the shape rather than with the geometry. And so if we just link S to S and T to T, and then we can hide the preview of this. So here is our initial shape, and then if we move over to the right, we can see the result. Now, notice that, as I said, it picks a random one. So if I relink this, there's a big chance, no, still the same. Yep, here we see it has picked another one because it randomly picks it. If we don't like that behavior, then of course we can easily say, well, let's use index 0. So the index number starts with 0. And we say, well, we don't want a random one. We want 0 to be picked. And, oops. Wanted to move it a little bit closer, but for that I will have to zoom in. Okay, and then, oops, still quite complicated. Well, this is a bit too much. Maybe like this. No, this note is really a bit too small to be able to move it. All right, there we go. And so this is a 0 and the other one is 1. If you put in a number greater than 1, it will just probably take the last one, or it will go around. I'm not quite sure, I remember, but in any case, it will not give an error. So let's zoom out a little bit. If you feel like this distance is a little bit too much, this distance is basically based on a calculation of the bounding box, and then probably taking this bounding box and duplicating it. We can shorten that here with the displacement x. So let's see, what we would like to do. Maybe we want the displacement to be something like 25. Let's try that. And then and feed this in here. And then you can see it will move it slightly closer. We could do it even closer, but now it will always do it at the same fixed distance. So it's better to be careful not to put it too close. All right, so this is basically, we've done the first rule application. And now, of course, we can do another rule application. So we can repeat this again. So we can have another SGI apply. Maybe we can put it behind it. Obviously, S should be the outcome of this, and we take the translated shape. That way, if we then translate it again, then it will, it will keep on moving. They will be sequentially organized one next to the other. And now we may want to translate one of the squares. And so we take this as a rule. And there you can see what happened. Again, it picked this randomly. Again, it draws it on top of it. But again, of course, we can take another SGI move shape, link S and T, and hide the preview, and then this is what we get. And this is, of course, not exactly the same result as Terry had presented. So, but what we can always do is, if we are looking for a particular result, I'm not, obviously there are 5 squares, and each square can be moved into 4 different directions. So there should be 20 different applications. And so I'm not sure, I could try all 20 to see which one particularly I want. But that's, of course, not very useful. So if we want to do a particular result, then the solution to that is actually say SGI apply all. I don't want to see just one application. I want to see all applications. And obviously, we want to do this with the same rule and with the same input shape. So this is the cross, and then okay, it's fine. Let's see. There are 20 results, so that's correct. We don't see anything because this is a list of shapes. There is no G, so there's nothing to show. So in this case, the best way to do this is actually to use move shape. So we have a list that goes into S. T as it transforms is actually also a list, so we can link this into. Let's hide this, turn on the preview for now, and then you can see these are the 20 different results. So if you want to have a particular result, let's say, for example, I remember that Terry Knight picks this one as the result, so then we have to start counting. This is 0, 1, 2, 3, 4, 5, 6. So if we choose 6 and link this in here, then we can show this, the preview, we can hide this, and then we have exactly the one that we might have wanted to select. And we can continue, of course. Now we can take this output, this output, and do another application. I will leave this as an exercise. The only thing I still want to show is, so we used, I will hide this again and turn this preview back. So what we see here is the 20 possible results. If instead of all the results we want to see all possible matches, then we have another component for that. Again, on the rule, there is SGI matches. So again, we do the same thing, the same rule, the same shape as input. And again, this gives a list of shapes of potential matches. So we're going to use another move shape, and I turned off the preview of the other. So these are the matches. Now let's see. There are 20 matches. This may be a little bit surprising because, in fact, as you can see, the first 4 are the same. And then the next 4 are the same, and then the next 4 are the same, and the next 4 are the same. I mean, they're in groups of 4, obviously. So why didn't it just show just 5 of them, the actual 5 squares? That's because there are 20 rule applications. And so it's basically showing the match for each rule application rather than each unique match. This is something to, so this of course doesn't quite give you the same information. You still couldn't derive from this exactly what is happening. But you can in other cases, for example, in the previous case, if we were to let's take this and move it backwards physically then, but basically we take the initial shape and apply to that the rules of the left-hand side and right-hand side. Then you could see, let's turn this preview off for now. Then you can see, okay, so this is the first match, and that is the second match. And it automatically puts these on top of one another. So this is very simple, and you can then do a series of rule applications, decide as many, you can put in the numbers, etc., and play with it, or look at the possibilities in each step and play with it like that. Okay, great, thank you very much.